Now that we've seen some example histograms in that course pack supplement, let's take a step back and kind of organize what we saw. So some of them were rectangular or uniform, like the age distribution in the US. Other things that are uniform is just rolling a fair die. You get the number 1 just as often as you get the number 2 or the number 3 or 4 or 5 or 6. Or if you're in a casino, a roulette wheel should give you equal probability of getting each number. The last digit of most serial sort of numbers, like phone numbers or social security numbers or driver's license numbers, is equally likely to be any digit between 0 and 9. Someone's birthday, like were you born on the 13th of the month or the 27th or whatever, that's fairly uniform within the number 0 to 30. Here I have a sample of some of 100 random digits, each 0 to 9, and I can get new samples here, so you can see how much the bars can bounce around. In theory, with 100 things and 10 categories, we would expect to see 10 things in each category. But apparently you can get up to 16 quite easily, or even down to only 4 in a category when you were expecting 10. So the point is here, don't be too concerned about deviations from being uniform. Here's what you get with 1,000 uniform digits, and that's staying closer to what we would expect for all level. Then we saw some things that were bell curve distributed. Inflation year by year was one of them. People's heights are generally kind of bell curve distributed. SAT, ACT, any big standardized test typically has bell curve distribution of scores. Any measurement errors, if you're working in a science or medicine lab, usually those have a uniform bell curve distribution. Here again I have 100 things that should be behaving like a bell curve, and you can see sometimes the histogram looks kind of bell curve-like, and sometimes it really doesn't. Like that, you would almost think could be uniform. So with just 100, it's really hard to say that's definitely not coming from a bell curve distribution. With 1,000, we get a little bit more predictability that it pretty much always looks bell curve shaped. Then we saw some skewed right distributions, and I guess we saw these. We kind of saw the number of children in a household had a skewed right distribution on the very first sheet, way back here. The number of people per car on the freeway, there's lots of cars that have only one person in them. Only a few cars have 2 or 3 or 4 people, so that's also right skewed. And here's our household income distribution that we've been using. Skewed left is much more rare. GPAs tend to be skewed left because there's a lot of people between 3 and 4. There's a fair number of people between 2 and 3, but they start doubting your academic progress if you stay below 2 for too long, and so there's a strong discouragement of people in the lower end of the tail. And then there's something called bimodal, bi meaning 2, mode meaning kind of fashion, and we saw the lawyers' starting salaries had one big bump in one place and one big bump in another place. You might think that men's and women's heights, if you graph them together, would have a kind of normal distribution for men and another for women, but it turns out they're so close to each other relative to the spread of individuals' heights that you don't actually get 2 separate bumps. Here's another one from data I've collected from students, asking them how many hours per week do you work on campus and how many hours per week do you work off campus. This doesn't look like 2 big bumps like the lawyer salary stuff did, but we really have a bump here of people who just don't have an on-campus job, and then out here is people who do, and over here is people who don't have an off-campus job, so they work 0 hours a week, and then here's people who do. So overall, when you're talking about a histogram, trying to describe it in a sentence or so, you should talk about its shape, say whether it's rectangular, uniform, or bell curve, or skewed right, skewed left, or bimodal. And then later we'll talk about its mean and median and stuff.